Like every other living creature, you are surrounded by smells that influence the way you think, how you feel, and how you react. The nose, in all its glorious shapes and sizes, is the gateway to this extraordinary realm of sensation. With every breath, the nose is an electronic sensor, detecting the smells around us and feeding information directly to the brain. Tom and Anna are on a date. Fine wines and food, the pleasure of each other's company. The key to all this will be their noses. Smell has the power to make or break their evening. It will give them an appetite and add enjoyment to their meal. And the very smells their bodies produce will affect how they react to each other. Smell is the most primitive of the senses, a simple chemical reaction with the environment, yet it puts us in contact with a world of information. The air around us literally smokes with scent molecules. The invisible vapor from a glass of wine fills the air with molecules carrying aroma. They bounce and crash into us, and once we draw them into our noses, the brain interprets them as smells. Most of this sniff of air ends up in the lungs, but 5% goes to the top of the nose, directly under the brain. Here, folds of moist flesh warm the passing air. Through the jungle of the nasal passages, the vapor flows up to a region packed with nerve endings, a mere quarter of an inch from the brain. Smell molecules dissolve in mucus and are trapped by hairy receptors. Hugely magnified, this region resembles a coral reef. There are 5 million smell cells packed into an area the size of a postage stamp. Feelers outstretched, they wait to grab a molecule. Smell is determined by the shape of the molecule. Different shapes are perceived as different smells. When a smell cell grabs a molecule, it shoots an electronic signal through a thin layer of bone straight into the brain. No other sense is so immediate. Aroma molecules come in an almost endless variety. The scent of good cooking can signal what's safe to eat and what's not. They can warn us of danger, whether it's the fragrance of roses on a summer's day or the stench of garbage rotting in the sun. A few molecules are all that's needed to trigger a response. Our sensitive nose is designed to sniff out odors, and it's placed to fulfill another important role. It's the main organ involved in taste. We use all our senses to enjoy our food and judge if it's fit to eat. The sight and smell of a shiny red strawberry makes your mouth water. Underripe, and you hear a crunch. A slithery feel in the mouth tells you it's overripe. Just the sight of this strawberry would make you think twice. Anna and Tom aren't having any problem with the look, feel, or sound of this meal. Eating is a feast for all the senses, but taste and smell predominate. Each of these foods contains dozens of flavor molecules, contributing to its unique taste. The moment food enters the mouth, our tongue and teeth take it on a roller coaster ride, breaking up the food so it's easy to digest. The tongue is the powerhouse of this attraction, tossing the food from side to side. After the food is well crushed, the tongue forms it into a compact ball for swallowing. As Tom chews, his mouth is checking out whether the food is safe and fit to eat. Hidden beneath the tongue's rough surface is a battery of sensors. They tell us whether food is hot or cold. They sample its texture and report back on its taste. Under the microscope, the secret world of the tongue appears. Taste, like smell, is a chemical sense. Here, a single taste bud lurks, waiting to capture flavor molecules. Drenched in sugar crystals, the taste buds in this tongue are busy sampling. Each part of the tongue has a specific job. It can detect only 4 different flavors: bitter at the back, sour at the side, salty at the front, sweet at the tip. Since only the tip of the tongue is sensitive to sweetness, ice cream takes on an extra tang when licked. But only for a while. Licked long enough, the taste buds go numb and the flavor disappears. Although the tongue plays its role, it's not the only organ involved. The best way to enjoy a mint is to crunch it, to release its concealed vapors. The vapor drifts up the back of the throat to the densely packed receptors at the top of the nose. This is where we sense its mintiness. And it's not just mint. Food vapors of all kinds assault our smell cells. 90% of what we perceive as taste is actually smell. Smell is 10,000 times more sensitive than taste. You can't distinguish foods when you have a cold because the aromas can't get up your blocked nose. Smell is what triggers the whole process of tasting. It makes your mouth water. Smell something tasty, and under your tongue, a saliva gland squirts into action. Saliva helps us to digest food and is essential for tasting it. The watery liquid dissolves flavor molecules, allowing them to react with our taste buds. We can't taste with a dry mouth. There's a third sense involved in tasting, a special kind of touch. Tom's just used it. Spicy foods and pungent smells stimulate the trigeminal, a super-sensitive nerve running around the inside of his mouth and nose. It makes our eyes water from hot curry or an unwise helping of mustard. But it's smell which dominates the savor of flavor. That's why professional tasters are called noses. These wine tasters know that their art is as much a matter of smell as taste. The room has been carefully prepared according to ritual. No flowers, no smoking, no smells that could distract their noses from the subtle message in a wine bottle. They have prepared their palates by avoiding harsh food and drink, such as coffee, which deaden the taste buds.
There's that gentle spiciness, isn't there?
The tasters protect their noses by avoiding aftershave or hairspray.
On est plus second, un avantage sur la
At the back of the palate when we finish.
This taster's palate is so sensitive, he can pinpoint the vineyard where a single grape was grown. He can even tell you the year. The soil, climate, and winemaking customs all subtly alter the chemical composition of wine, and thus the taste. A wine connoisseur can spend years training his senses, sniffing freshly sawn oak logs, sucking lemons so he reacts instantly to acidity, taking mouthfuls of cold tea loaded with tannin. He can instantly recognize these tastes and dozens of others that make up the complex flavor of a wine. The taster uses all his senses. He checks the color of the wine, then swirls it to release the vapors. This odd gargling releases more of the wine's flavor molecules. The wine delivers its 4 basic tastes to the tongue. As he draws air through the warmed wine, the back of his nose is filled with its complex aroma. Tom and Anna don't have trained noses, but their sense of smell is still incredibly sensitive. A tiny change in just one of the 600 chemical components of coffee, and it seems bitter. Smell is unique among our senses. It has the most direct route into the brain. The olfactory nerves that pick up smell are virtually an extension of the brain itself. And unique among brain cells. They renew themselves. Smell cells continually divide and grow. You get a new nose every 2 or 3 weeks. Blast out your taste buds with a really hot chili, and they too will regrow. The nerve cells in the nose fire straight into the limbic system, the brain's memory bank. Smell something once, and you'll never forget it. The reaction is ingrained in all humans, an age-old defense mechanism that protects the body. Eat or drink something that makes you sick, and it will always repel you. But smell's survivalist roots have an unexpected consequence. With a whiff of candle smoke, we feel the excitement of Christmas or the solemnity of church. The scent of the sea can take us back to childhood vacations. Smell is the most evocative sense, deeply connected with memory and the emotions. Smells can excite or relax us. They can arouse us or make us romantic. An aura of mystery surrounds this elusive power of the brain, captured in the ancient art of perfume making. No words can truly describe aromas, so perfumers borrow terms such as green, sharp, even caring. For centuries, perfumers have created their own secret recipes from a range of fragrant ingredients. Roses and jasmine provide sweet aromas. Citrus fruits and berries, a sharper scent. An exotic touch comes from spices, vanilla, dried roots, oak moss, incense, and myrrh. Synthetic smells can provide the pungency of a snuffed-out candle. Every perfume house has its own library of smells, the fragrance of roses, the zest of lemons, all captured in a bottle. Blending these ingredients is the essence of the perfumer's art. Scientists may analyze the scents chemically, but no amount of technology can replace the perfumer's nose. Smells have become part of our perceptions. The sharp scent of fresh lemons seems clean. The sultry tang of jasmine on a gentle breeze whispers romance. Smells are tightly bound to memory, and the human factor is an essential part of the recipe. A professional perfumer has a working knowledge of over 1,000 fragrances. She blends aromas as a composer combines musical notes. Sniff the perfume. The first smell is like the top note of a musical chord. It's the most volatile ingredient, and it soon evaporates, leaving more lasting fragrances, the middle and base notes of her composition. The evening's going well. Anna's determined not just to look good, but to smell her best too. Smell dominates our lives, consciously and unconsciously, from the moment we are born. Smell and taste are a baby's first senses, working when his sight and hearing are still poorly developed. The first taste buds developed when the fetus was just 7 weeks old. He may have acquired some food preferences then. Spicy aromas get into the fluid-filled womb. While breastfeeding, the infant is learning more about the flavors of his mother's world, the aroma of what she eats. Maybe even the perfume she wears gets into his milk. Soon, these tiny food critics develop taste preferences. If the mother has been eating garlic, most babies will suck longer. They'll take less if she's had a glass of beer.
Tiger baby.
The early bond between mother and baby is forged through smell. His first smell is his mother. From the 6th day of life, he can single her out by her smell, although he can't recognize her by sight. A hanky carrying her scent will calm him down. And it's a two-way process. She can pick out her own child's garments from a pile of cast-off clothes. One sniff, and the effects can spread to all corners of the brain. As a woman samples perfume, a brain activity scan demonstrates the power of smell. Hot spots light up in the front of the brain as it stirs memories. Areas in the visual cortex at the back show she's picturing a scene. The brain of a 3-month-old baby shows an even bigger reaction. His first smell of chocolate floods all parts of his brain with sensation. And there it is again. Smells can trigger the pituitary gland, which controls the body's hormone system. Its chemical messengers influence our health and our moods. Clearly, smells play an important role in human behavior. They may even put us in the mood for love. Perfume is intoxicating, but the smells our bodies produce have the strongest effect on other humans. As we get closer, or simply hotter, we begin to produce our own body smells, an odor as individual as a fingerprint. The smelliest regions are our armpits and sex glands. Here we have huge numbers of glands producing oil and sweat. Each of us has 2 million sweat glands. Sweat itself has no smell, but bacteria break down the secretions and release body odor. A whole colony of bacteria thrive on this single hair, plucked from a smelly armpit. This woman is waging chemical warfare against body odor. She is a deodorant tester, a soldier in the battle against offendingly foul bacteria. We go to a lot of trouble to disguise our natural smells, but the most potent of all sex attractants is secreted by our own skin. A molecule called a pheromone may make ardent lovers out of us all. Many foods are said to be the messengers of love. Although scientists dispute that aphrodisiacs exist, all these foods have a startling common thread. They contain a chemical identical to human pheromone. This molecule, found in human odor and in aphrodisiacs, is also similar to the male sex hormone testosterone. Incredibly, they are alike, except for a couple of atoms. Is this just a chemical coincidence? Or have the romantics been right all along? Get within sniffing distance and sexual attraction can begin. Despite our primary reactions, smell signals pass beyond our primitive brain to our conscious mind. No matter how tempting, we cannot necessarily be led by the nose. The air around us is filled with a symphony of conflicting smells and sensations. We may never understand them, but we cannot ignore the elusive mix of mystery and memory that is the power of smell.